Welcome to Balaya Matrices. Learn every step. Show that the vectors 3 to 7, 2, 4, 1, 1 minus 2, 6 are linearly dependent and express one of these vectors as a linear combination of other vectors. Let me take this is x1, x2 and x3. Coming to the solution, let x1 is equal to 3, 2, 7, x2 is equal to 2, 4, 1 and x3 is equal to 1 minus 2, 6. Let us write the linear combination and equate it to 0. Let us take the scalars lambda 1, lambda 2, lambda 3. That is, the linear combination of the vectors is lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 equal to 0. That means lambda 1 into 3, 2, 7 plus lambda 2 into 2, 4, 1 plus lambda 3 into 1 minus 2, 6 is equal to 0. Let us write in the equation form of this linear combination. That means 3 lambda 1 plus 2 lambda 2 plus lambda 3 equal to 0. 3 lambda 1 plus 2 lambda 2 plus lambda 3 equal to 0. And 2 lambda 1 plus 4 lambda 2 minus 2 lambda 3 equal to 0. And 7 lambda 1 plus lambda 2 plus 6 lambda 3 equal to 0. This is just like a homogeneous system of equations. So let us write in the matrix form as Ax equal to 0. The coefficients 3, 2, 1, 2, 4, minus 2, 7, 1, 6 into lambda 1, lambda 2, lambda 3 equal to 0, 0. This is of the form A lambda equal to 0. Let us say this is a lambda. Okay. So now you have to reduce this one into echelon form to find the rank of the matrix. You know very well how to find the homogeneous system of equations. If rank is equal to number of unknowns, the system has 0 solution. If rank less than number of unknowns, the system has infinitely many solutions. If rank is equal to number of unknowns, the given vectors are linearly independent. If rank less than number of unknowns, given vectors are linearly dependent. Let us see what will happen for this matrix. Now use this element and make these two elements as 0. That means R2 tends to 3R2 minus 2R1 and R3 tends to 3R3 minus 7R1. Then this becomes no change in the first row 3, 2, 1, 6 minus 6, 0, 12 minus 4, 8 minus 6 minus 2 minus 8. And similarly 3 7s are 21 minus 21 which is 0. So 3 minus 14 minus 11 and the 6 3s are 18 minus 7. 18 minus 7 11 into lambda 1 lambda 2 lambda 3 equal to 0 0 0. Now use this element and make this one as 0. That means R3 tends to 8R3 plus 11R2. Then this becomes 3, 2, 1, 0, 8 minus 8, 0, 0 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0. What you have noticed? Yeah, this is in echelon form. So the rank is 2 because you have 2 number of non-zero rows. Rank is 2, number of unknowns are 3, rank less than number of unknowns. The system has infinitely many solutions. That is, the vectors x1, x2, x3 are linearly dependent. Therefore, rank of A is equal to 2 less than 3 is equal to n. That is, the vectors x1, x2, x3 are linearly dependent. To find the solution, let us write the equations. 3 lambda 1 plus 2 lambda 2 plus lambda 3 equal to 0 and lambda 2 minus lambda 3 equal to 0. As rank less than number of unknowns, so the system has infinitely many solutions and n minus r linearly independent solutions. How much? N minus r is 3 minus 2, which is one linearly independent solution. So you need to take one variable as a constant. Let lambda 3 as k. Let lambda 3 is equal to k. That implies lambda 2 is also k. That implies by substituting these two in this one, 3 lambda 1 is equal to minus 2 lambda 2 minus lambda 3, which is minus 2k minus k, which is minus 3k. That implies your lambda 1 is minus k. Therefore, the values of x are minus 1, 1, 1 into k. So, let us substitute these values by taking k as 1. Then, lambda 1 is minus 1, lambda 2 is 1, and lambda 3 is also 1. That means, this can be written as 327 is equal to 241 plus 1 minus 2, 6. You can easily notice that 2 plus 1, 3, 4 minus 2, 2, 1 plus 6, 7. That means one vector can be written as linear combination of other vector. This is the way how to observe the linearly dependence of vectors. And one vector can be represented as the linear combination of other vectors. Let us see one more problem. Show that the vectors 1, 1, 1, 3, 1, 2, 3, 4, 2, 3, 4, 9 are linearly independent. First of all, let us say these vectors as x1, x2, x3. Now, let us write the linear combination of these vectors by considering the scalars lambda 1, lambda 2, lambda 3. You need to equate that one also to 0. So, lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3. Consider lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 is equal to 0. That is, so lambda 1 into 1, 1, 1, 3 plus lambda 2 into 1, 2, 3, 4 plus lambda 3 into 2, 3, 4, 9 equal to 0, 0, 0, 0. Now, lambda 1 plus lambda 2 plus 2 lambda 3 equal to 0. Lambda 1 plus 2 lambda 2 plus 3 lambda 3 is equal to 0. Lambda 1 plus 3 lambda 2 plus 4 lambda 3 is equal to 0. 3 lambda 1 plus 4 lambda 2 plus 9 lambda 3 is equal to 0. These are the equations. So let me write the equations. Lambda 1 plus lambda 2 plus 2 lambda 3 equal to 0. Lambda 1 plus 2 lambda 2 plus 3 lambda 3 equal to 0. Lambda 1 plus 3 lambda 2 plus 4 lambda 3 equal to 0. Lambda 1 plus 3 lambda 1 plus 4 lambda 2 plus 9 lambda 3 is equal to 0. This is homogeneous system of equations. You can write the matrix form of this system. That is 1, 1, 2, 1, 2, 3, 1, 3, 4, 3, 4, 9 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. This means a lambda is equal to 0. Let us say the equation says a lambda is equal to 0, which is homogeneous system. Now, let us reduce this one into echelon form. Then you can easily verify whether the given vectors are linearly dependent or independent. So that R2 tends to R2 minus R1. R3 tends to R3 minus R1, R4 tends to R4 minus 3R1. If you do so, no change in the first row, 1, 1, 2, 1 minus 1, 0, 2 minus 1, 1, 3 minus 2, 1, 1 minus 1, 0, 3 minus 1, 2, 4 minus 2, 2, 3 minus 3, 0, 4 minus 3, 1, 9 minus 6, 3. Lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. Now use this element and make these two elements as 0. That means R3 tends to R3 minus 2R2 and R4 tends to R4 minus R2. 1, 1, 2, 0, 1, 1, 0, 0, 0, 0, 1 minus 1, 0, 3 minus 1, 2. into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. Now interchange R3 and R4. Then you will get the rank of the matrix. That means R3 if and only if R4. 1, 1, 2, 0, 1, 1, 0, 0, 2, 0, 0, 0 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. The rank of the matrix is 3. Number of unknowns are also 3. When the rank and the number of unknowns are equal in homogeneous system, the system has 0 solution, which is trivial solution. Therefore, the system has a trivial solution. That means your lambda is equal to 0. That means lambda 1 equal to 0, lambda 2 equal to 0, lambda 3 is also 0. That means in the linear combination, if all the scalars are 0, then you can say that the vectors x1, x2, x3 are linearly independent. Let us solve one more problem on linearly dependent and independence of vectors. Here, show that the vectors 1, 1, minus 1, 1, 1, minus 1, 2, minus 1, 3, 1, 0, 1 are linearly dependent. Also write one of these vectors as a linear combination of other vectors. Let x1 is equal to 1, 1, minus 1, 1. x2 is equal to 1, minus 1, 2, minus 1. x3 is equal to 3, 1, 0, 1. Now, consider three scalars such that lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 is equal to 0. Choose lambda 1, lambda 2, lambda 3 scalars such that lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 is equal to 0. Lambda 1 into 1, 1, minus 1, 1 plus lambda 2 into 1, minus 1, 2, minus 1 plus lambda 3 into 3, 1, 0, 1 is equal to 0. That means 0, 0, 0. Now you can see that these can be written as in equations. Lambda 1 plus lambda 2 plus 3 lambda 3 equal to 0. And lambda 1 minus lambda 2 plus lambda 3 equal to 0. Minus lambda 1 plus 2 lambda 2, 0 into lambda 3 is equal to 0. And lambda 1 minus lambda 2 plus lambda 3 equal to 0. Now you can write in matrix form of this system of equations. How? 1, 1, 3, 1 minus 1, 1, minus 1, 2, 0, minus 1, 2, 0, 1 minus 1, 1 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. You can notice that this horizontal vector can be written as a column of the matrix, and this one is also second column, and this one as third column. Now let us say this is a lambda equal to 0. Let us reduce this one into echelon form to show whether the given vectors are linearly dependent or independent. That's why R2 tends to R2 minus R1, R2 tends to R2 minus R1, R3 tends to R3 plus R1, R4 tends to R4 minus R1. That is, no change in the first row. 1, 1, 3, 1 minus 1, 0, minus 1, minus 1, minus 2, 1 minus 3, minus 2 again, minus 1 plus 1, 0, 2 plus 1, 3, 0 plus 3, 3, 1 minus 1, 0, minus 1, minus 1, minus 2, 1, minus 3, minus 2 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0, 0, 0, 0. Now use this element and make these two elements as 0. That means R3 tends to 2R3 plus 3R2. Multiply this one with 2 and multiply this one with 3 and add these two, because one is minus and another is plus, so that this will becomes 0. Now R4 tends to R4 minus R2, then minus 2 plus 2, 0. That means 1, 1, 3, 0, minus 2, minus 2, 0, 0, 0, 0, 0, 0 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. What you have noticed? This is in echelon form and the rank of this one is 2 because number of non-zero rows are 2. Therefore, rank of A is equal to 2 but number of unknowns are 3 which is less than 3 the number of unknowns. That means the given vectors are linearly dependent. Therefore, the vectors x1, x2, x3 are linearly dependent. Okay. Now, let us find how to write one of these vectors as a linear combination of other vectors. To find the values of lambda 1, lambda 2, lambda 3, let us write the equations. That means lambda 1 plus lambda 2 plus 3 lambda 3 equal to 0 and lambda 2 plus lambda 3 equal to 0. Lambda 2 plus lambda 3 is also 0. As the rank is less than number of unknowns, the system has infinite number of solutions and we have to consider one variable as a constant. Let me take lambda 3 is equal to k. Let lambda 3 is equal to k. That implies lambda 2 becomes minus k. Let us substitute these two values in your equation 1. So let us say this is equation 1 and this is 2. Then lambda 1 is equal to minus lambda 2 minus 3 lambda 3. Upon substitution of lambda 2 as minus k, this becomes k minus 3k, which is minus 2k. Therefore, lambda becomes something into k. That something is nothing but lambda 1 minus 2 into k, lambda 2 minus k, and lambda 3 k. So, if you take k value as 1, these are the values of lambda 1, lambda 2, lambda 3. Let us substitute these values in your linear combination, which was equal to 0. That means minus 2 into x1 minus 2x1 minus x2 plus x3 equal to 0. Minus 2x1 minus x2 plus x3 is equal to 0. Just I have to take these two terms to other side. Twice x3 is equal to x2 plus 2x1. Here you can observe that third vector can be written as a linear combination of first two vectors x1 and x2. This is your scalar 2 and this is your scalar 1. Lambda 1 x1 plus lambda 2 x2 is equal to lambda 3 into x3. That means one vector can be expressed as linear combination of other vectors. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.